Hey guys, today I want to walk you through some solving in equations using logarithms and exponents. The ones I'm going to show you today are equations that all look like they're in exponential form, and we're going to solve those using logarithms. Okay, so if this is the first equation that we're working on, 2 to the x power equals 7. The way that we're going to solve that equation is we're going to put it into logarithmic form. Notice I only have one variable up here, and it's on obviously only one variable. It's on one side of the equation. So putting it straight into logarithmic form gives me log base 2 of 7 equals x. Oh, I didn't throw it away a minute ago. Log base 2 of 7 equals x. Okay, now that's just something straight from last week's work, putting things in logarithmic form from exponential form. Okay, so this is something though that we can put straight into our calculator to get our answer. Let's make a calculator page and go log base 2 of 7 equals, so that's 2.807. So x equals 2.807. And just as a reminder, you can use the calculator on your phone to do these if you remember the change of base formula. Change of base formula being, in this case, log of the argument, so log of 7, divided by log of the base, log of 2. Remember, this puts it in log base 10, and while our calculator can do any base that we want, calculators didn't used to be able to do that, so that's something that we've always known how to do as a change of base formula. It's also something that you can do in this calculator. Okay, well, obviously not on this page. If we turn it in sideways, here we have log. Notice that it's only log base 10 and log base e, which is natural log, so we can't actually do this problem on our phone calculator if we know the change of base formula. So we would do 7 log divided by 2 log, enter. Same thing, 2.807. Okay, just as a reminder with the change of base formula. Remember, that is when you have it in logarithmic form, it's the log of the argument divided by log of the base. Okay, again, that puts everything in log base 10, which most calculators can do. All right, so this is our answer in this case. We could obviously check it. 2 to this power would equal 7. Now, it's actually not going to equal exactly 7. Can you think about why that would be true? Yep, we rounded. Okay, now this is close enough to know that that it would actually be 7, especially if we think about the fact that we did round the answer. Okay, now what happens if it looks like this? Because this looks way messier. There's multiple variables, there's multiple exponents on each side, or as an exponent on each side. This is actually a relatively simple problem if you think about it. 5 to 3x plus 4 power equals 5 to the 5x plus or minus 2 power. If 5 to this power equals 5 to this power, shouldn't those two powers actually just equal each other, and we don't even have to involve logarithms or exponents at all? Well, that's true. Okay, 5 to any power equaling 5 to any other power, those two powers have to equal each other. So I can just go straight down to here. Okay, 3x plus 4 equals 5x minus 2, and we solve this, well, if I could write the right thing, we solve this doing exactly the same thing we've been doing for years and years. 6 equals 2x, so x equals 3. Now, this for sure, again, all of these are we definitely want to plug in the answers to make sure that we're correct, because then we know with confidence that this is the right answer. Okay, if I substitute 3 in here, I get 3 times 3 is 9, plus 4 is 13. If I put it in this side, 5 times 3 is 15. 15 minus 2 is 13. We don't care what 5 to the 13th power is. We just know that 5 to the 13th power equals 5 to the 13th power. And that's all it takes for us to know that this is the right answer. Okay? Now, what if it looks a little bit more complicated? Does that mean it is more complicated? Well, no, you know that by now. Okay? What if it looks like this? Well, what kind of things do you think we would have to do first? Well, if we treat this thing like just the variable, we just do what we know that we're supposed to do. First thing we would do is add 7 to both sides. Once I add 7 to both sides, I get 2 times e to the 2x power equals 12. And then again, I'm still treating this like the variable, because although e is not a variable, that's a constant. I just have to ignore it for now because that's where the variable is. It's in its exponent. So I divide both sides by 2, which gives me e to the 2x equals 6. Guys, this is the same thing now as this problem was over here. It's just a problem written in exponential form, and if it's in exponential form, to take it out of exponential form, I write it in logarithmic form. Okay? So I could write log base e of 6 equals 2x, but I definitely don't want to do that because of the fact that log base e, we already know what log base e is. We don't write log base e. What do we write instead? Natural log. So I have natural log of 6 equals 2x. To solve for x, I'm going to divide both sides by 2. And that's just a matter of, again, in our calculator, natural log of 6 divided by 2. Oh, but I don't want it on the inside, do I? Divided by 2. Point x equals 0.896. .896. Okay. Again, I want to go back to the original problem and substitute that in. 2. And the e that I want to use is not the letter down here. Remember, it's this button right here, the e to the x power. E to the 2 times, and then what we got is our answer, 0.896, and then minus 7. That should equal something close to 5. Now notice it is not exactly 5, it is close to 5 because once again we rounded, so we're not going to get exactly the exact answer. Okay, but that is close enough to 5 for us to know that this is the correct answer with confidence. Okay. Now the quote-unquote problem comes when it looks like this. Okay, when it looked like this, I had the same base, so I could just take those exponents and set them equal to each other. No biggie, right? Well, what if I don't have the same base? Here I have a base of 5, here I have a base of 25. It's a problem unless you think about it. Okay? If you think about the fact that we can adjust this a little bit, this is going to stay the same that it is. This is going to be adjusted because I could actually write 25 as 5 squared, can't I? Isn't that the same as 25? Well, remembering our rules of exponents, when I have a power to a power, what happens? Power to power of powers? I multiply those powers, right? Well, I have 5 to the x minus 3 power equals 5 to the 2x minus 10 power. I just multiply that out. Distribute that 2 to each one of the terms in the exponent right there. Well, now I just have a situation almost exactly like I had in this problem over here, where I just have x minus 3 equals 2x minus 10. Because 5 to this power equals 5 to this power, so those two powers should equal each other because the bases are the same. Okay? Again, we're just going to solve like we know how to solve. X equals 7. For sure, we want to check. This one's going to be a little bit more difficult because we don't want to go here. We want to go back to the original problem just to make sure. So I have 5 to the 7 minus 3, which is 4. And then I have 25 to the 7 minus 5, which is 2. If you need to plug that into your calculator, you can. 5 raised to the 4th power and 25 raised to the 2nd power. Those do both equal the same thing, but again, you could think about the fact that this is 5 squared, and 5 squared squared is 5 to the 4th. So 5 to the 4th does equal 5 to the 4th, but again, 5 to the 4th is 625, 25 squared is 625. Either way you look at it, it is correct, and this is the correct answer.